Now we are going for the next lecture is phase shift keying. So the phase shift keying we have studied until now amplitude shift keying and phase frequency shift keying. Amplitude shift keying is resembling the amplitude modulation of the analog communication. Similarly, frequency shift keying resembling the frequency modulation in the FM system, that is angle modulation system. Here, phase modulation also resembling the angle modulation system, only the phase modulation system in the analog communication. So it is we are started to study the binary phase shift keying. So it is a binary, you know that one, the levels are either 0 or 1. So phase shift keying is another form of the angle modulated constant amplitude digital modulation. So both FSK and PSK, the constant amplitude, the will not be vary the amplitude, whereas the amplitude modulation, that is ASK, the amplitude will vary, as we have already studied in the analog communication. So now the BPSK is the form of square modulation of a continuous wave signal. So vary the phase shift of the carrier signal to represent the digital data. So as already given as the phase shift keying, so that varying the phase shift of the carrier signal to represent the digital data. So the mathematically the phase shift keying is represented by S of t, that is S1t for the t is symbol 1. So again it is a 2 EP by TB cos 2 pi FCT, the carry is the same, single carrier we are doing. Similarly S2t is nothing but a phase shifting of the pi. So it is the equal pi is nothing but equal to opposite signal, so that is the minus of the 2 EB by this one. So for the symbol 1 it is a one direction, that is a positive direction. So for the symbol 0 it is a negative opposite direction, so it is a 180 degree phase shift. So that we are calling a 1 and 0, so that it is a in phase and the opposite direction, so that only the two phases are there. So that we are calling it the binary phase shift keying. So again the same thing, mathematical equation we have given. So it is resembling like this. So it is the 1 it is the positive direction and 0 is the opposite direction, it is the negative. So for example we have taken as a binary signal here is a 1 0 so like this, and then correspondingly BPSK is like this. So it is a positive, when the positive is there the signal is a positive, when 0 is there 180 degrees phase shift, so that is the 180 degrees phase shift like this. Again positive 180 degree phase shift. So whenever the signal the bit 0 it is the opposite sign, that is a negative or 180 degrees phase shift is there. So this is what we are calling the BPSK output here. So clearly it is given here sin omega ct, or you have to represent either sin or cos sin omega ct, and for negative minus sin omega ct like this. Then BPSK transmitter and receivers. Now let us see the BPSK transmitter. BPSK transmitter is simply nothing but we are representing it is again a multiplication of the carrier signal with the modulating digital signal. So here the modulating signal, digital signal we are representing in terms of the bipolar bit stream. So either positive or negative, both voltages are there. Similarly the receiver, again the same signal, again we are multiplying with the carrier signal, it is the basis function, and again is the low pass filters like a block here, and then we are taking the decision device either 0 or 1. So this is the BPSK receiver. So more or less it looks like a ASK transmitter receiver and a BPSK transmitter receiver more or less look like same, but only the change here it is the input stream is the bipolar, whereas in the ASK it is the unipolar. So similar to the FSK, bit error rate also is given by the directly, the probability of error is given by the equation like this, and the corresponding there are various problems as being given like here. Now again the quiz test for the BPSK. Find the bit rate and baud rate of the following BPSK signal. So this is the answer. So since it is the 5 bits, that is the bit, each signal element is a one signal element for the each digit. So for one digit it is a one signal element, so that 5 bit rate, so that baud rate also 5.